Hey guys, I'm Christina. Today I'm going to talk to you guys about potentials. Local, resting, and action potentials. Resting potential. Resting potential describes the actual value of the electrical potential of the plasma membrane when it is at rest and ready to send a signal down its length. It exists across the plasma membrane and reflects the ionic differences in the cytoplasmic and extracellular side of the membrane. Leakage channels, non-graded ion channels, and sodium-potassium pumps help maintain that polarized state, which describes the plasma membrane when it is at rest and the ICF is -70 MV. The causes of resting membrane potential. A cell has a resting membrane potential because electrolytes are unevenly distributed between the extracellular fluid on the outside of the plasma membrane, sodium, and the intracellular fluid on the inside, potassium. The resting membrane potential is an effect of four different factors such as diffusion of ions, sodium and potassium, down their concentrated membranes due to leakage channels. Selective permeability of the membrane, allowing some ions to pass more easily than others. The electrical attraction of cations and anions to each other. Sodium diffuses inward and potassium diffuses outward. But with the sodium-potassium pumps, it is continually compensates the leakage. As a result of the diffusion of these ions, the ICF becomes more and more negatively charged. Soon, ICF exerts a stronger attraction for the positive potassium ions and attracts them back into the cell through the sodium-potassium pumps until equilibrium is met and potassium is entering and leaving the cell at equal rates. Local potential. Local potential is short-range change in voltage along the membrane. It is distinguished by four characteristics. 1. Local potential is graded, meaning it varies in magnitude according to the strength of the stimulus. 2. It is decremental, meaning they get weaker as they spread from the point of origin. This prevents local potential from having long-distance effects. 3. It can either be excitatory or inhibitory. Excitatory is usually considered which depolarize a cell and make a neuron more likely to produce action potential with the effect of acetylcholine. Other neurotransmitters like glycine does the opposite. They hyperpolarize a cell or make it negative, making it less sensitive and less likely to produce action potential. Local potential process. Stimulation of a neuron causes local potential in the membrane. Example, chemical stimulus. The response begins at a dendrite and spreads through the body. Example, sodium channels open to allow sodium to flow into the cell. Then travels down the axon. Example, sodium inflow cancels some of the internal negative charge, so the voltage across the membrane shifts to zero, reducing the membrane polarity. Ends at the axon terminal. Example, incoming sodium diffuses short distance along the plasma membrane, creating a wave of depolarization that spreads from the point of stimulation. Action potential. Action potential is a more dramatic change produced by voltage. Graded ion channels in the plasma membrane, they occur only where there is a high enough density of voltage graded channels. It is a rapid up and down shift in voltage. Action potential process. Local potential at action Hillock is strong enough to cause a current that depolarizes the membrane at its threshold value, negative 55 MV. Sodium gates open and sodium ions rapidly diffuse from the extracellular fluid to the intracellular fluid, causing the membrane potential to rapidly depolarize from negative 55 MV through 0 MV and eventually to positive 30 MV. Sodium gates cause the potassium gates to open, causing potassium ions to rapidly diffuse from the ICF to the ECF. The membrane potential now rapidly repolarizes, and the existing cations cause the membrane potential to become more negative, eventually returning to negative 70 MV. Resting membrane potential, producing a negative overshot called hyperpolarization. Potassium gates close, and now with both gates closed, the sodium-potassium pumps can return the cations to their original locations.